Hello everyone. We are starting the topic of conversion from a binary number into a decimal number and vice versa. What exactly is a decimal number? A number that is based upon the digits 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. The different combinations of these give rise to different numbers that we come across in everyday life. What is the binary number? Binary number is based upon two digits, as the name suggests, binary, the digit 0 and the digit 1. The computer understands the language of binary number. The computer is unable to comprehend what a decimal number is. That is why in the subject of physics, we need to understand how to convert from a binary to a decimal, and similarly from a decimal to a binary number. Each digit is called a bit. There could be a 4-bit number, there could be a 5-bit number, that could be a 8-bit number. A 4-bit number, a group of digit, is called a nibble, whereas an 8-bit group of digit is called a byte. So now the word byte, it's very familiar to every single person that uses computer to whatever extent. Now if I make a claim that a 4-bit number can give me 16 different values of decimal, how can I convince you that this thing is correct? That conviction will come from the concept of counting principle of statistics. If I have two possibilities and I want to form a 4-digit number, there are two possibilities for the first digit and two possibilities for the second and two for the third and two for the fourth. That means the number 2 is multiplying by itself 4 times. According to indices, that is 2 raised to power of 4, which is 16 possibilities. That means if I want to think about a 5-bit number, a 5-digit number involving 0 and 1, I can draw a similar diagram, and that diagram will have 2 multiplied by 2 multiplied by 2, 2 multiplied by itself 5 times, which is 2 raised to power of 5, which is 32. That means if I look at this table, there are 16 possibilities for a 4-digit number, 32 possibilities for a 5-digit, 64 for a 6-digit number, 128 for a 7-digit number, and 256 for an 8-digit binary number. That means if I focus on the 4-bit number, the decimal value would range from 0 till 15, which we will see in a short while. Similarly, a 5-bit number, the decimal value will range from 0 till 31, 6-bit 0 till 63, 7-bit 0 till 127, and so on. So now these electronic circuits that you see, the combination of whether these LEDs light up or doesn't light up, that is all dependent upon this concept of binary numbers. Now from the basic math, we need just very basic of indices. We need these 4 numbers. Since we are focusing on a 4-bit number, any number raised to power of 0 is 1. That's why 2 raised to power of 0 is 1. 2 raised to power of 1 is 2. 2 raised to power of 2, that means 2 multiplied by 2, which is 4. And 2 raised to power of 3, that is 8. That means if I make a table, binary power, binary weight. So basically, in simple words, what it means is that just remember this combination in the order given. Starting from the largest, 2 cube, 2 square, 2 power 1, 2 power 0. Remember the magical words, magical digits 8, 4, 2, 1. These 4 digits will help us to convert from a binary number into a decimal number. Let's look at this binary number, a 4-bit number, that is 0000. Now our objective is, we will go through a lot of examples. Our objective is to convert from this binary into a decimal number. So remember that series of number, 2 cube, 2 square, and 2 power 1 and 2 power 0. So over here I have written in ascending order from right to left, and what I have to do is this: evaluate the four values in the purple: 2 cube, 2 square, 2 power 1, 2 power 0. That's 8421. Now multiply each red value with its corresponding purple value and add it up. 0 into 1 plus 0 into 2 plus 0 into 4 plus 0 into 8. Of course, in this scenario, it will all add up to 0. That means 0, 0, 0, 0. The 4-bit binary number is in fact corresponding to the decimal value 0. So that's how you do the conversion. It's as simple as it seems. Let's look at another example. Another binary value 0001. So now this time, instead of writing 2 power 0 and 2 power 1, 2 power 2, 2 power 3 from right to left, why don't I write the magical four numbers 8421 in that order? Multiply, 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 multiply and add it up. What do I get? I get 1. That means 0001. In fact, the decimal value is 1. That means if I want to input 1 in the computer is strong enough, capable enough to convert that decimal value of 1 as 0001, and that's how the working would start. That's the background working. That's behind the stage working that the computer is doing for us. Another example, 0010. What do you write at the bottom? 8421. Now do the mental calculation for yourself. Think for 3 seconds. Actually, 3 seconds is less. Think for 10 seconds. Time's up. 0 into 8, 0 into 4, 1 into 2, 0 into 1. What do you get? I get the decimal value 2. Another example, 0011. Right below it, 8421. Multiply, 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 multiply and add it up. I get the decimal value 3. So that's how easy it is to convert a binary number into a decimal number. Just remember this magical combination 8421. We are focusing on the 4-bit binary number. Last example of binary to decimal 0100. Multiply correspondingly with 8421 and you get the answer as 5. Another example 1010. Multiply it with 8421. Multiply each term carefully, add it up, you get the decimal value 10. Now the next part of the video, this is about conversion from a decimal into a binary. Over here I need the concept of basic division. Now what's in basic division that I need? I should be aware of 3 terms: the quotient, divisor and remainder. For example, if I take the number 9 and if I divide by 2, I know the answer is 4.5, but I don't need that answer. I need the answer in terms of divisor and quotient and remainder. 9 is being divided by 2, so 2 is the divisor, 4 is the quotient and 1 is the remainder. So now my focus is on quotient as well as the remainder. Done? Let's move on. For example, if I want to carry out the division of 7 divided by 2, 2 3s are 6, remainder is 1. Right now, focus is on the remainder. If I want to divide 8 divided by 2, 2 4s are 8, remainder is 0. That means our focus will be on division by 2. Either the number will leave a remainder of 1 or it will leave a remainder of 0. Does it ring any bell? Yes, it should, because 0 and 1 are the basis of binary numbers. 2 more examples of division. 2 divided by 2, that is 1, remainder is 0. And the last example of basic division, 1 divided by 2, I'll use the word STOP, that means stop. We won't do the division, because 1 is smaller than 2. We would stop there, right then. Now, let me take a decimal value 15. Now, the working is based upon the fact you will keep on dividing by 2. Keep the quotient on the side, remainder on one side. Repeat the division with the quotient. Let's have a look. 15 divided by 2, that is 7.5, but I need the quotient, which is 7, and what is the remainder? 1. Repeat the same process with 7. 7 divided by 2, that is 3, is the quotient, remainder is 1. Then repeat the process with 3. 3 divided by 2 is 1, remainder is 1. And what did I tell you? When you see the number 1 remaining and dividing by 2, what is the English word I should use? STOP. You should stop there. I am looking for a 4-bit number. So this one that I made you stop, I'm circling these 4. And now I'm starting from the very last value. That is the most significant bit, MSB. So I'm starting from 1, then the blue remainder 1, then the red remainder 1, then the pink remainder 1. That means my answer is 1, 1, 1, 1. So that's how I obtain from a decimal value, I obtain a binary value. Look at the working again. 15 divided by 2 is 7, remainder is 1. Keep the remainder on the side. Repeat the process with the quotient. 7 divided by 2 is 3, remainder is 1. 3 divided by 2 is 1, remainder is 1. Now this orange quotient, I cannot proceed any further because 1 is smaller than 2, so I would stop over there. That quotient that is left, that is my first figure. Then this one, then this one, then this one. Therefore, the answer is starting from bottom all the way up. Look at the direction of the arrow. So 1, 1, 1, 1. That is my binary number. Let's choose another one. Let's choose the digit 14. 14 divided by 2 is 7. Remainder is 0. 7 divided by 2 is 3. Remainder is 1. 3 divided by 2 is 1. Remainder is 1. And 1 divided by 2, STOP, stop. So now look at the 4 blue circle. The lowest one, that is the first digit, 1, 1, 1, 0. So that is the binary number. Pretty simple, provided you follow the arrows. Let's look at another one. Let's look at the decimal value 11. 11 divided by 2 is 5. Remainder 1. 5 divided by 2 is 2. Remainder 1. 2 divided by 2 is 1. Remainder 0. And the quotient 1, I don't even need to write it. I can just circle it and write STOP. So now, without me guiding you, think of it. 1 is in the box with stop. So the first digit is 1. Then 0, 1, 1. So 1, 0, 1, 1. That is the 4-digit binary number that we obtain. The most significant bit is 1, then 0, then 1, and the last significant bit is 1. That's how you get it. So this is MSB, and this is LSB. Let's move on. Let's look at the number 8. 8 divided by 2 is 4. Remainder 0. 4 divided by 2 is 2. Remainder 0. 2 divided by 2 is 1. Remainder 0. And stop. What is the answer? 1, 0, 0, 0. Therefore, that is the binary 1, 0, 0, 0. Clear? Now, let's look at this example, which is about 7. 7 divided by 2 is 3. Remainder 1. 3 divided by 2 is 1. Remainder 1. And I cannot proceed any further. This time I have to stop. So The number 1 is in the blue stop box. Then there are other two ones. So this is 111. But isn't it supposed to be a 4-bit number? So whatever is available, first write it. Which place is empty? The very first digit is empty. The most significant bit is empty. So by default, the most significant bit would come out to be 0. So 0, 1, 1, 1. That is the working for the decimal conversion of 7. Look at it again. Instead of 3 stages like this one, like this one, like this one, how many stages does it have? It has 2 stages. So you get a stop 1, then a red remainder 1, then a pink remainder 1. That is the 3 digits. And since the first digit is empty, you write a 0. Okay, let's move on. Another example. Another example is that of the number 4. 4 divided by 2 is 2, remainder 0. 2 divided by 2 is 1, remainder 0, and then STOP. How many digits do you see? I see a red 1, I see a red 0, a pink 0, that's 3 digits, and the most significant bit is 0. Have a look at it again. So the working for 7 is similar for the working for 4. And now the last example of the conversion, that is the decimal value 3. 3 divided by 2 is 1, remainder 0, and then you just stop there. This is just one step of working. So you have 1, and of course you also have the pink remainder 1, so 1, 1, and the first 2 significant digits, they are 0, 0. So what is the answer? 0, 0, 1, 1. Now, in physics, you come across a question like this. This is from the A-level science application booklet, and the graph is given for signal versus the time in microseconds. A vertical line bar is drawn, and you see all the values of the voltages, and you want to convert these voltages into binary, and you have learned it. The voltages, for example, the first voltage is in a decimal value, and what are you converting? It as a binary value. Or they could give you a binary question and they can ask you to convert it into a decimal question. So I hope this particular video will help you understand the conversion binary to decimal and decimal to binary. Take care.